Hey guys, what's up and welcome back. Now just go ahead and understand that how you can deploy Docker containers on AWS Cloud. And before that, we just launch a small prototype on our local machine because we want to understand the differences between launching the containers on the local machine and doing the same thing or achieving the same outcome on cloud. Because in terms of the scope, in terms of the number of components involved, in terms of the complexity involved, there's a huge difference. Now, as you can see on my screen, I already have a Docker desktop application installed on my MacBook. You have to pre-install this thing so that you can also install the Docker daemon, which allows you to manage the backend processes in terms of pulling the images, running and stop the containers, everything. So I'll be using the terminal to launch a simple NGINX container on the local machine. We'll just have the container up and running. We're going to test it. And thereafter, we'll see that what is the process involved in terms of launching the same type of container on AWS cloud infrastructure. So just go ahead, open my terminal. Now you can use the command prompt on the Windows if you want. So you can use any inbuilt terminal on your machine, whether it is the command prompt on the Windows or the MacBook terminal or the Linux terminal. So you can see that in my case, this is my terminal that's being displayed on the screen right now. Now, if I run the command docker ps-a, it shows me a list of the containers, whether stopped or whether running. So irrespective of the state, it will show me the list of the containers. As of now, there is no container or there are no containers being running. So let's go ahead and launch an NGINX container. So let's do the command docker run -d in detached mode. So this is to run this container in detached mode. Then I just assign a name to it. Let's name it as NGINX -container. And then I'll do the port binding. So I just use -p. First, we have to define the host port. So that case, it's 8080. Now in this case, what's a host? I would say, what's a host for this container that we're going to launch? This machine or the computer or the MacBook or the laptop that you're using, that's a host machine. So we're opening this or enabling this port 8080 on the host machine on which this container is set to be deployed. Then we have to bind it. So after colon, you have to include the container port 80 in this case. So this is the port number that will be opened on the container that we're going to launch. So we're using -p and binding the port 8080, the host port, with the container port 80. Finally, we just go ahead and include the name of the image that will be used to deploy this container. Now, what's an image? An image is nothing but it's a read-only template from which we just extract or deploy the container. It's a standalone executable, or I would say lightweight package of the software, which contains everything to deploy the container, including the code, the runtime, system libraries, system settings, system tools. If the images are being made to run on the Docker engine, they become containers. So I define the NGINX as the image name, and that's it. Let's press enter. And let's wait for this thing to pull the image first, because I don't have the image which is being downloaded or which is stored locally. If it is pull the image from the Docker Hub, which is a public repository, and then it will just create a container out of that. As you can see that it's being done. So let's see. Run the command docker ps-a, and yes, I have this container running. If I just run the command, for example, docker images, I can see this is the image that was downloaded or the pulled, or it was extracted, or it was pulled from the Docker Hub before launching a container out of that one. Now, how to test this container? To test it, I'm just going to go ahead and just look for the localhost port 8080, which is the host port. So I can use this localhost 8080. I can access the web application or the website. I would say the page being displayed. I'm trying to basically try testing the container. So I'm running this NGINX web application locally and able to access its HTML page. So as you can see that this is successful. There's a small prototype And we have seen that how to launch a simple NGINX container on the local machine, on the local development environment. Now let's see what happens if we want to get the same outcome, the same container to be up and running in AWS Cloud. Now you'll see there will be a wide difference. So in this case, let's go to the AWS Management Console. And the service that you're looking for, or you should be looking for, is the Elastic Container Service. Now it's a container management service. It is fast, it is highly available, and it allows you to run, stop, and manage Docker containers. It is a one-stop destination. It's a container orchestration platform for you. Now there's a three-step procedure that you have to follow along to deploy your container. Number one is that you have to deploy a cluster. Number two, you have to create a task definition. And number three, you have to create a service. So this is a three-step procedure: cluster, task definition, and service. So these are the components that need to be configured or built one by one in this sequence so that we can create a container that's an NGINX container in our case. Let's go with the cluster first. So on the left-hand side, you can see that we have this clusters. Now what's a cluster, by the way? A cluster is nothing but it's a group of the container instances or its infrastructure on which the containers are being placed. Let's go and create cluster. And this cluster picks a random name, an auto-generated name. It says stylish shark and with some random digits. Now you can just go with this one, or you can just assign a custom name to it. I just go with the custom name or the default name. Let's go with the default name. So I just go with the default name and not customize it. It's purely your choice. So this is the name of the cluster that I have been assigned, or that's being auto-assigned to this one, this cluster. And the next thing that you have to select is the infrastructure, which is the underlying resources that you have to assign to the cluster. Now, what I mean by underlying resources, what do we mean by the infrastructure in terms of this ECS service? We need to understand one thing, that these containers are being placed on some compute servers. Those compute servers, at the end, I would say, behind the scenes, we have the virtual machines or the EC2 instances being up and running on which the containers would be placed. Now, under the infrastructure, we have to define whether those containers, or I would say whether those container instances would be managed by us, or whether they will be managed by AWS, or we want to go purely serverless. If you want to go with serverless, then we have to choose Fargate. Now, what is Fargate? It is a serverless compute engine for the containers. Of course, we get convenience. We don't have to manage, scale, load balance the containers behind the scenes or the container instances, but we don't get the transparency in terms of the management of those containers. We don't see the containers at all, so we can't manage them. So serverless means that the scalability, load balancing, management of the container instances / servers on which the containers are running would be managed behind the scenes without your interference. Then you have Fargate managed instances. Managed instances means that to a larger extent, the scalability and the management and the patching will be done by your cloud provider. But I want to go with the Fargate and self-managed instances. Now, what are self-managed instances? Self-managed instances are the container instances that you manage and control 100%, which means that you have full control upon those container instances, starting from the configuration, the management, the scalability, the load balancing. It's in your hands. So you get complete control over the underlying infrastructure if you go with the self-managed instances. And that's what I'm doing in my case. Now, these container instances can be auto-scaled. I just go to the on-demand provisioning model in terms of these instances. And these instances will be using the Amazon ECS optimized AMI. Now, what is this Amazon ECS optimized AMI? Now, this is a special AMI which helps you to deploy your container instances with two special packages. Number one package is the ECS agent, and the number two package is the Docker daemon. ECS agent is the special package, or it is also called container agent. So it allows the container instance to register itself to the ECS cluster. So every single container instance that would be running in my cluster need to get itself registered with the ECS cluster. So who facilitates that? The ECS agent. The second one is a Docker daemon. Docker daemon is also being pre-installed with this package. When we use ECS optimized AMI, the Docker daemon is also installed. The Docker daemon is installed so that the ECS plane or ECS control plane that's been managed by AWS can send instructions to these Docker containers. So the container's entire life cycle is being managed through that ECS plane, but those instructions are being sent to the Docker daemon running upon these instances. Overall, the ECS optimized instances contain two special packages, ECS agent and the Docker daemon. We just go the Amazon Linux 2023 base AMI or the ECS optimized AMI. We are not going to change it. In terms of the hardware, let's go with the t2.micro instance type, and let's select that. All right. Now, what about the EC2 instance role? We'll just go with the ECS instance role. Now, this is the role that my container instances may need to do some, or to, I would say, to perform special API requests or to send some API requests behind the scenes to the services internally. Again, you can just go with the default role if you want. Now we have to set the desired capacity of the minimum number of the container instances 1 and maximum as 5. So this means that it will always ensure, because we're using auto scaling to manage our underlying infrastructure, if we ensure that minimum 1 and maximum 5 container instances are always up and running to support my containers. We don't have to go with the keep here. We don't have to change any of these settings down below. Let's go ahead and click on create. So it's going to create a cluster, and it will start with the minimum number of the container instances. In our case, that's 1. Now this can take some time to be up and running. So in the meantime, we will just go ahead and create a task definition. See, cluster is nothing but it is a group of the container instances up and running to support your containers. We run the containers in the form of tasks upon these container instances that are clustered together in the form of a cluster, ECS cluster. But we have to set a blueprint for these different container instances. I would say containers on the container instances. So we have to set a blueprint for the tasks or the containers to be launched on the cluster. Now, what is blueprint? Or what is task definition? A task definition, you can see that on the left-hand side, we have the task definitions. A task definition is a blueprint in the JSON format. I repeat, a task definition is a blueprint in JSON format, which tells Amazon ECS service how to launch or run a Docker containerized application, while including some important details. For example, the image to be used, the ports to be opened, the volumes to be used, networking, logging, CPU and memory requirements, the roles to be assigned, every single nuances, or I would say every single detail, fine detail, the nuances, the details, every single thing is being included in the form of parameters in the task definition. While using these parameters, while referencing these parameters, Amazon ECS will create by running tasks. Where these tasks will be running? Upon my ECS cluster. Okay, so my cluster is created. So let's go to the cluster first. Let's visit the cluster right now. I just go to the cluster right now. I just go to the infrastructure. So you can see that this is the capacity provider. So I've used auto scaling to manage my underlying infrastructure. And this is the container instance that's running. So let's go ahead and go to the task definition because our cluster is being formed fully. It is completely deployed. So let's go ahead and create a new task definition. Let's name this as NGINX demo TD. That stands for task definition. That's it. And what's the launch type? I just go the Amazon EC2 instances because we are managing the instances by yourself. So yeah, this is what you have to select under the infrastructure requirements if you are going with the same parameters as I'm selecting. Okay. What about the OS architecture network mode? We'll just go with the Linux x86 64-bit architecture. Network mode would be AWS VPC. Now, there will be a separate lecture on the network mode. By default, it's AWS VPC network mode. this renders or assigns a dedicated ENI to each of the tasks running, which means that ENI is the Elastic Network Interface, right? So if you use the AWS VPC network mode, every single task that will be launched will have a dedicated Elastic Network Interface assigned to it, which will assign the capability to that task to communicate with other networks inside or outside. So it allows the task to be the part of a network, whether it's local or whether it's external. So you have to go with the default network mode, that's AWS VPC. Now this is very important. Task size. Now you have to be very much, I would say, cautious, or you have to ensure that the task size is being selected with utmost precision, or you have to be careful about that. So you have to make sure that the size of the task is lesser than the size of the container instance on which it will be running. This task, or I would say the task, each task that we're going to launch will be launched where? On the container instance. If I go to clusters right now, okay, let me just right click and open the clusters in a new tab. Let me show you something. If I just go to the clusters right now, this is the cluster that we have launched. If I just go to the infrastructure, this is my container instance that's running. Now the task that we're going to launch will be placed where? On this container instance. This container instance, if you see its CPU and memory allocation, the CPU available is one virtual CPU only, because we went with the T2.micro instance type. So it has bare minimum specs. We can't expect a lot out of that one. Of course, if you have, I would say you have requirements. If you want to have more CPU, more RAM, then you have to change the instance type. So we chose the instance type T2.micro because we didn't have too much of the requirements in terms of the CPU and memory requirements. We're just doing this for the testing purpose only. So the T2.micro instance type gives you one virtual CPU and less than 1 GB RAM. That's bare minimum, right? Of course, you can run some production workloads, but most of the times you just go with the higher instance types, which offers you, or they will offer you more CPU and memory. Now, why did I highlighted the CPU available and the memory available? Because while keeping this thing in mind, we have to set the CPU and memory allocation for the task to be placed upon these container instances. So I just go to the task definition and I just go with only 0.5 virtual CPU and 0.5 gigs of RAM. Now you have to make sure this value is less than the container instance value, because you can't exceed that. You can't have a larger container running on a smaller container instance, because if it's just try to do that, this will lead to an error. So we have set the task size. We have set the amount of CPU and memory to reserve for our task. The next thing is the task role. The task role is needed by the task to perform some API request or perform API actions. No need for that one. Task execution role, you can just choose create default role, and if this is already there, ECS task execution role, you just go with that one. This is used by the ECS agent or the container agent running upon the instance to make some API request on your behalf. So you can just go with this one. Now comes the image. First, you have to set the name of the container. So I just name it as NGINX -container. This is the name of the task that will be up and running. Image URI. So I name it as NGINX without any specific version. Now this image will be pulled from the Docker Hub, the public repository. Then the port mappings, I choose so by default, it's the container port is 80, protocol TCP. I just name this as container-port, and app protocol is HTTP. Now this is relevant in our case because we're going to launch an NGINX web application. So of course, port 80 or HTTP 80 traffic must be allowed. And I guess everything is okay, except one thing. This logging option or logging optional needs to be, I would say, unselected. It needs to be unchecked. So logging means that the containers that will be running, the tasks that will be running, would send certain logs to the CloudWatch. And we can use those logs for troubleshooting, to look into certain ongoing issues. This is for debugging and troubleshooting going forward. So you have to uncheck this option, because in this case, we just do the hands-on. The containers, the tasks that we're going to launch are short-lived in our case. So it doesn't make any sense to just set up the logging for these short-lived containers that we're going to launch. Everything looks perfect as of now. And we have to just go ahead and just create this task definition. So as we have seen, the task definition is nothing but it's a collection of certain parameters, image, then CPU and memory allocation, or CPU and memory requirements for each of the tasks that we're going to launch, and the ports to be opened. Right, so these are some important parameters that must be defined before we can create a service. Now, what is service? So there are two steps that we have performed as of now. We have accomplished two important steps. Number one, we created a cluster, which is a group of container instances. In our case, the cluster that we've launched is containing only one, or has only one container instance for us. Okay, so we didn't go for more container instances because one is more than sufficient for us to just test this thing. So if I just go to the infrastructure, you can see that there's one container instance that's up and running, and that's more than sufficient for us as of now to just test that how the containers are being deployed and managed using ECS. The second thing that we did was that we just created a blueprint. Now, why this blueprint was created? Why this task definition was being created? It was created because now we have to define a service while referencing this task definition. What I mean by that? So I just go to the cluster right now. I click the cluster, and there's a menu option which you can see just left to the task. The very first one, that is the services. Now, what is a service? A service is nothing but it's a scheduling logic which maintains the desired number of tasks up and running across your container instances in a cluster. So it maintains healthy number of tasks, desired number of tasks up and running. Now, what's a task? It's a running instance of a task definition. A task represents one or more containers. So you can say that the services, or a service, is used to maintain the desired number of containers in the form of tasks up and running, ensuring that if any of the containers or the tasks become unhealthy, then they will be replaced with the healthy ones. And also it takes care of the scalability and load balancing. You can put a service behind a load balancer. Let's go ahead and create a service while using the task definition. So when you just create a service, the very first detail that it asks for is a task definition. So you have to choose this one. This is the revision. This is the first version of this task definition family. This is the name of the service, which is auto-generated. You can just go with the auto-generated, or you can just assign your own label. It's up to you. You don't have to change the capacity provider strategy because we are using the self-managed instances that are being managed by the auto-scaling behind the scenes. So you don't have to change that. Deployment configuration, by default, it's replica. This will maintain, I would say this will place and maintain a desired number of tasks across our cluster. What is the desired number of tasks in our case? It's one only. So in our case, we'll just go with only one task deployment. Only one task, that's it. And the next thing that we have to configure is the networking. Under networking, you don't have to change the VPC because in my case, I'm using the default VPC to deploy my cluster into, or to deploy my task into. So again, I'm not changing that one. So all my resources are being managed within this default VPC in the region of Frankfurt. The main thing that I have to choose is the security group. I have to create a new one. Now, why I want to just create a new security group or the firewall for these tasks to be placed. Because one thing you need to understand, the containers of the tasks that we're going to launch, or in this case, only one task we're going to run, is an NGINX container or the NGINX task, which is there to offer the browsing capabilities. I would say that we want to access the NGINX web application over the browser, using the browser. So using the browser, we want to access the web page or the web application that we're going to launch, because we're going to launch an NGINX web application. So in that case, even though we've opened the port 80 on the container side, but on the firewall side, which is the security group that we're going to configure, we have to also open that port as well. It picks the default name of this security group. We can just keep it as it is. Make sure you choose HTTP traffic over port 80 from all the sources. So you have to choose anywhere. That's it. So even though the port 80 is opened on the NGINX container, which means that, of course, there's no restriction from the container perspective, but the firewall that is being applied to my containers, you also have to include these ports or the protocols as well. The last thing, but not the least, is that we just put this service behind a load balancer. So I just go to the load balancing, which is optional. Choose use load balancing. Now, of course, the load balancer will be in the same VPC where all my infrastructure is running or will be managed behind the scenes. The load balancer type in our case would be the application 1. The container at the port to load balance the incoming traffic to would be, this is the container name, and the traffic will be sent to the port 80. That's it. We'll just create a new load balancer. We're just going to name this as NGINX demo LB, which stands for load balancer. So you don't have to change the list of configuration. We'll just create a new target group which will contain these container instances. So let's go ahead and name it as NGINX demo TG. Right? So my service will run behind a load balancer. This service will consist of the containers running behind the scenes. So we are grouping these containers behind the scenes in the same target group. Now in this case, of course, we have just one container or one task running. You don't have to change other attributes. Keep them as it is. And let's click on create. So in terms of the implementation, it is done. The only thing that's been left out is the testing part. Now this can take up to 5 minutes to fully provision itself, because of course the cluster is already deployed, the task definition is already being created, the blueprint is already being created, it's already in place. The only thing that's been left out is that we have to place the tasks upon the cluster while extracting the blueprint from the task definition. Now, these tasks are being grouped together in the form of a service and put behind a load balancer. Now, this entire process will take up to 5 minutes to finish itself. So I just pause this video and resume this once this is being done. And thereafter, we're going to test our deployment. Welcome back. Now, as you can see, in my case, the service is up and running. And if I just go to the tasks on the right-hand side, we just went only with one task only. And this is also up and running. Now, how to test our deployment? So we have to go to the EC2 dashboard because we want to access the load balancer's DNS name. So let's open that in a new tab. And let's go to the load balancers. And we deploy the load balancer. This is the one. Let's copy its DNS name. Let's paste it in the browser and let's wait. And here we go. So this is the same outcome that we got when we deploy the container. So if I just go to the tab on the left-hand side, that we access this same application using the localhost 8080. But now we are accessing the same application because now this containerized application, this Docker containerized app is deployed where? Not on the local machine, but on the cloud. So that's where you can draw the differences. What I want to showcase is that launching a container on the local dev environment and launching a container on the cloud infrastructure are two separate things. The scope, the scale, the amount of configuration, the amount of attributes required, the components required, it's at a very high level if you just go with the same deployment on the cloud itself. Because see, one thing we need to understand, cloud is not just to launch and run your containers. It is a complete container orchestration experience, or I would say, platform for you. It is not just launch the containers. It is the management, scalability, load balancing, applying firewalls like security groups. So a lot of things are included when you deploy the containers on the cloud platforms. Now, once you're done with this thing, it is always important that you just delete your load balancer first. So just go to the actions and delete the load balancer. Just delete that. And you can also go ahead and delete your task definition. Now, the task definition can be, you can just go ahead and choose the task definition revision, and then you can just go to the actions and deregister that. Okay, you can deregister your task definition, and thereafter you can just go ahead and delete your cluster. Now this will make sure that you don't get overbuilt or overcharged for these resources. So I'll just type in delete, followed by, let's copy and paste the name of the cluster so that this cluster is also being removed eventually. And this will take 2 to 3 minutes to finish its removal process. Now you can see this error message coming up. It says container instance deregistration. And this is a very common bug or error. You just hit retry and this will go away eventually. And in the meantime, this is getting removed. You can remove the container from your local machine. Now, again, this is not being built. So just to make sure that you just remove that container, you can, okay, so what you can do is that, let's clear this thing out. Just run the command docker ps-a to see a list of running or stopped containers. And you can copy and paste the container name or the container ID. First you have to stop it. So docker stop followed by the container name or the container ID. And then docker rm and container name. So if I just run the command docker ps-a, that's gone. And what about the Docker images? So if this go to or run the command docker images, I can see the list of the images. Now you can just remove this image because it takes a bit of space. In my case, it's taking 180 megabyte. So I can copy the image ID. So I can just type the command docker rmi and the name of the image. That's removed. If I run the command docker images, no image. So I've also removed every single thing from my local machine as well. And if I just go to the cluster, this is also on the verge of getting deleted. So I hope this was informative. Thank you so very much.